This lesson, we're going to be revising topics from the Shape 1 module. Let's jump right in. The first topic was the perimeter of a shape, and we can be asked in questions to find the perimeter of shapes such as the ones below. So remember, the perimeter is the distance around a shape. So perimeter equals distance around a shape. Okay, so for example, if we look at question A, the perimeter is the length of all four sides of this rectangle here. Okay, so how can we figure this out? Well, I know that this side is 12 centimeters, therefore I know that this side is also going to be 12 centimeters. Because I know this side is 6 centimeters, I know that this side will be 6 centimeters as well. So I can see I've got two 12 centimeters, so I can do 2 times 12 centimeters. I'm going to add that to, I got two 6 centimeters, so 2 times 6 centimeters. Okay, I'm going to solve both of these. So 2 times 12 centimeters, 24 centimeters. Ooh, too many m's there. And 2 times 6 centimeters is 12 centimeters. So 24 centimeters and 12 centimeters is 36 centimeters. There you go, job done. Now let's have a look at another question. So now looking at question B, we're dealing with a triangle here now, okay? Now, I know this is an isosceles triangle because of these two red lines that come through the shape. So these, not red lines, they were black lines. So those lines mean that these two sides are exactly the same length, okay? So if I know that this side is 6 meters, I know that this side is also 6 meters, okay? So all I need to do now is add up the lengths of all the sides of this triangle, okay? So I'm not going to bother multiplying anything. I'm just going to add them all together. So I'm going to do 6 centimeters plus 6 centimeters plus 8 centimeters, okay? So 6 plus 6 gives me 12 centimeters. I still need to add the 8 centimeters. And 12 centimeters plus 8 centimeters is 20 centimeters. And that's our final answer for this question. Let's move on to the next topic. So now we're looking at area of rectangles, okay? So remember, the area of a shape, or the area of rectangles, is the base times the height of the shape. Okay, so that's the formula for the area of a rectangle, okay? Remember, the area is all of this space that the shape takes up, okay? So that's the area of the shape, okay? So let's work out for question A first of all. So first of all, we need to do area. The area equals base times height. Okay, so what's my base? Well, the base of the shape is 4 centimeters. So I can write 4 centimeters. And the height is 2 centimeters. So I need to multiply that by 2 centimeters. 4 centimeters by 2 centimeters. Well, that will give me 8 because 4 times 2 is 8. And because we're now dealing with area, the units will be centimeters squared. Okay, so centimeters and just a little 2 to the side of it, okay? So that's our answer for the first question, 8 centimeters squared. Let's have a look at the next one now. So question B, so we've got another rectangle. We need to find the area of this rectangle. So remember, area equals base times height. So we don't know the area, but the base of the shape, now there's a lot of numbers flying around here, but they're all the same. So same as the last rectangle, the base is this bottom number, so 10 meters. and the height is this side here, which is 3 meters. So 10 meters times 3 meters. Now bear in mind the units are different to this one, okay? So the first one we were dealing with centimeters. This one we're dealing with meters, okay? So always double check the units. So 10 meters times 3 meters. Well, 10 times 3 is 30. And because we're working out an area, the units will be meters squared, okay? And that's the answer to this question. Let's move on to the next topic. So now we're being asked to calculate the area of each triangle below, okay? And remember the formula for the area of a triangle. So area of a triangle equals half times base times height. Okay, or you might have seen it as base times height divided by 2. Okay, so there's two different ways you can think of the area of a triangle. It's either the half times the base times the height, or base times height divided by 2, whichever one you find easier. Okay, I quite like using this one. Okay, base times height divided by 2. So that's what I'm going to do for this one. So looking at the first question, question A. So we're going to need to find the area of this triangle. Now remember again, area is just the space that the shape takes up. Okay. So remember our formula, area equals base times height divided by 2. So what is my base? Well, the base of this triangle is 6 centimeters. So I've got 6 centimeters multiplied by, well, the height is this side here. That's 4 centimeters. So 6 centimeters times 4 centimeters. I'm going to divide all of that by 2. Okay. So let's work out the 6 times 4 centimeters. Well, 6 centimeters times 4 centimeters is 24 centimeters. So I've got 24 centimeters. 24 centimeters divided by 2. Well, I know that is going to be 12. So that's going to be 24 centimeters squared, sorry, because we multiplied two distances. So 24 centimeters squared divided by 2 will be 12 centimeters squared. Okay. And that's our final answer for the area of the first triangle. Let's have a look at the next triangle now. So again, area equals base times height. Divided by 2. Okay, very important that. So what is our base? Well, the base is the bottom number here, which is 10 meters. Units have changed to meters now. Now the height. Be careful with this now. So the height, have a look at these numbers. So 6 meters, 6 meters, and 4 meters. Which of those lines goes vertically upwards from the bottom of the shape to the top of the shape? So which line goes in a straight line up? Well, it's the 4 meters, okay? So the actual height of the shape is 4 meters, okay? So be careful. When you're measuring the height of triangles, you always want a line going straight from the bottom to the top, okay? So now we know the height is 4 meters. We're going to do 10 meters times 4 meters. And we need to divide all of this by 2. We don't know what equals yet. So let's do 10 meters times 4 meters. Well, 10 times 4 is 40, and because it's an area, because we found an area, or meters times meters, it's going to be 40 meters squared. Okay, we need to divide that by 2. 40 meters squared divided by 2, that will give us 20 meters squared. Okay, and that's your final answer for this question. Let's have a look at the next topic. So now we're going to look at the area of a trapezium. Okay, now this formula is a bit of a mouthful, so hopefully you remember it. So the area of a trapezium now the actual formula is just a half a plus b times height. Okay. So well done if you remember it's half AB plus height. But let's just remember what the A and the B are. Okay. So the A is the top of the shape and B is the bottom of the shape. Okay. And then height is height. So we know what height is. Okay. So this is the formula we're going to use to answer these questions. Okay. So let's have a go. So we've got question A here. So area, tell you what, the next line down, area equals a half times A plus B times H for height. Okay. So we got a half and we're going to multiply that. So what's A? A was the top of the shape. So we've got 3 centimeters. We need to add that to the base of the shape, which is 5. So 5 plus 3 centimeters. I'm going to times that by the height. And remember, that's the line is to be, the height is a straight line from the top to bottom. Okay, so that's going to be 4 centimeters. So here we've got all our numbers. Okay, so let's work this all out now. So let's do 3 plus 5 first of all. So we're going to have a half times 3 plus 5 is 8 centimeters. And we need to multiply that by 4 centimeters. Okay. So let's do this first. So what is a half times 8 centimeters? Or what is half of 8 centimeters? Well, that's just 4 centimeters. And we still need to multiply by this 4 centimeters here. So 4 centimeters times 4 centimeters. So 4 times 4 is 16. And remember, because there's 2 centimeters multiplied by each other, our answer is going to be centimeters squared. And that's because we're dealing with an area. Okay. So this is the answer to the first trapezium question. Now the second one, there's no B in there. Let's label that part B. So part B now, okay, so again, so we've got area equals a half A plus B times H for height, okay? So let's put these numbers in. So we've got a half. A is the base, or the top, or the bottom is the top, sorry. So we've got 7 millimeters. So A is 7 millimeters. B is the base, which is 9 millimeters. Times that by the height. Remember, it's the vertical height, so I'm going to use the 6 millimeters. So times by 6 millimeters. Okay. So first of all, let's add these two together. Okay. So what is 7 plus 9 millimeters? Well, that's going to be 16 millimeters. Okay. And that's going to be a half times 16 times 6 millimeters. Okay. So again, I'm going to find out what a half times 16, or what is a half of 16? Well, that's going to be 8 millimeters, and I still need to multiply that by 6 millimeters. So 8 times 6 is 48. And because we're dealing with areas and the units are millimeters, it's going to be 48 millimeters squared. Okay, and that's our final answer for the second question. Okay, let's move on to the next topic. So area of parallelograms. Now, these are slightly trick questions, because even though they look very intimidating and they'll give you loads of different lengths and sides of the parallelograms, the formula for this is very easy. Okay, the area of a parallelogram, yep, all it is base times height. Okay, and that's all it is, base times height. Okay, now the trick in these questions, even though the formula is quite simple, base times height, the trick in this question is making sure you correctly identify what is the base and what is the height. Okay, so let's have a look at the first one. So we've got question A here. So remember, area equals base times height. Okay, now in this question, the base is easy. We've got a nice straight line going here, so we can see the base of this shape is 12 meters. Okay, nice and easy. Now we've got two different options for the height of this parallelogram, okay? But if you think back, just like with triangles, the true height of the triangle is the line that is going straight up, okay? It's not diagonal, it is going straight up, okay? And hopefully you can now see that the distance that is pointing straight up on this shape is the 5 meters, okay? So we don't need the 4 meters at all in this question, okay? So 12 meters times the height we decided is 5 meters. So 12 times 5 meters. And so 12 times 5 is 60. And because this is an area and the units are in meters, it's going to be 60 meters squared, okay? And that is the final answer to this question, okay? Now, let's have a look at the second one now. So we got question B here now, okay? So this one's a little bit trickier because the parallelogram seems to have been turned around a bit, okay? But actually we can still, if we imagined that even though this shape has been rotated 90 degrees, we could still call this distance the base because it is a straight line going across. Or we can call the 15 centimeters the height because it is a straight line going up. Okay, so even though the shape has been tilted slightly, we can still say because these are straight lines, one going straight across and one going straight up, we can call these the base and the height of this parallelogram. Okay, so let's write out the formula. So area equals base times height. And we said we're going to call 2 centimeters the base because it's a straight line going across. So we're going to have 2 centimeters there. And the height we said is the straight line going up or down. So we're going to call that the 15 centimeters. 2 times 15 is 30. And because they're both the units are in centimeters, the area of this shape will be centimeters squared. Okay, that's your final answer to this question. Let's move on to the next topic. Volumes of a cuboid. Now, again, the formula for this one, once you know it, these questions are nice and easy, okay? So volume of a cuboid okay? And all this, the formula for this, so it's the base times the height times the depth of the shape, okay? We like to simplify this just down to B times H times D, okay? Base times height times depth, and that's all you need to find out the volume of a cuboid, okay? So again, it's important to recognize what these distances are, okay? But it doesn't actually matter what order you do them in there. It doesn't matter which order you multiply them. As long as you've got the numbers right, you can multiply them in any order if you wanted. So let's have a look at this one. So question A. So the area, we said it was base times height times depth. The base, well, this is the bottom distance here, so I'm going to call that the base, so that's 7 meters. The heights, that's the distance vertically up. I'm going to call that the 4 meter because that's the distance going straight up. And the depth is how far the shape goes back, and that looks like the 2 meter is the depth, okay? So I've got my 3 numbers now, and now we just need to multiply them together, okay? So you can do this any order you want. I'm going to do, I'll do 7 times 4, first of all. Now, because it's 7, so we can do 7 times 4. So 7 times 4 is 28. But because we're multiplying 2 lengths together, our answer is going to be 28 meters squared, okay? So what we've essentially done, when we do 7 times 8, we found the area, the surface area of this part of the shape, okay? And that's going to be, that's an area, so the unit has to be meters squared, okay? And we still need to multiply this by 2 meters, because that's how deep the shape is, okay? So 28 times 2 is 56. But because we're doing meters squared times a meter, the units will be meters cubed, okay? And remember, when we're dealing with volumes, the units will always have a little 3 next to them. That means it's meters cubed, okay? So this is the final answer to this question, 56 meters cubed. Okay, let's move on to the next one. So question B now. So again, area equals base times height times depth. Now, shape B, I'm only told that one side is 3 millimeters. So that's my base done. So I can see that the base is 3 millimeters, but I'm a little bit stuck as to what the other sides of the shape could be. Now the hint is in the question here, because I'm told up in the question that shape B is a cube. And I know that with a cube, all sides are the same length, okay? So if the base is 3 millimeters, that must mean that the height is 3 millimeters, which also means that the depth of the shape is 3 millimeters. So because all these distances are the same, I now know what the base, height, and depth are going to be if I'm told one of the sides. So the base was 3 millimeters, the height is also 3 millimeters, and the depth is also 3 millimeters. Now I just need to multiply these together to get my final answer. So 3 millimeters times 3 millimeters, well, that's going to be 9 millimeters squared, okay, because it's millimeters times millimeters. I still need to times it by 3 millimeters. So 9 times 3 is 27. And because my answer is now a volume, my answer will be millimeters cubed. Okay, so millimeters with a little 3 on the end, okay? And that's my final answer for part B, okay? Let's have a look at the next topic. So now we're going to look at calculating surface areas of cuboids, okay? So there is no explicit rule or formula to follow with calculating the surface area of cuboids, but there is a little method, and I'll try and write that down for you now. So the surface area of a cuboid. So first of all, you need to find the area, not the surface. You need to find the area of the front of the cuboid. You need to add that to the area of the side of the cuboid. You need to add that to the area of the top of the cuboid. And once you've found all of those, you multiply that by 2. Okay? So the area of the front, the side, and the top of the cuboid, if you multiply that by 2, you will then get the surface area of the cuboid. Okay? So what does that look like in practice? Well, let's have a go at using this in practice now. Okay, so let's have a look at question A here. So first of all, I need to find out the areas of the front, the side, and the top of this cuboid. Okay, so the front of the shape, so that's the front here. So I need to find the area of this area here, and that is going to be 6 times 4 centimeters. So 6 centimeters times 4 centimeters. 6 times 4 is 24. And because I'm dealing with an area, it will be 24 centimeters squared, okay? Now for the side, this is the side here. So I need to find the area of this panel here. And that is going to be, well, the base of this shape is 3 centimeters and the height is going to be 4 centimeters because it's the same as the height over here, okay? So for the area of the side, I need to do 3 centimeters times 4 centimeters. 3 times 4 is 12, and because it's an area, it's going to be centimeters squared. Then for the top, I need to find the area of this panel here, and it's going to be the same as the front actually, because we can see we've got 6 centimeters there. Okay, so now we're going to figure out the area of the top panel here. Now that's going to be this area here, okay? So if we think about it, we know that this side, the length of this distance over here is going to be 6 centimeters, but this distance here, that's going to be 3 centimeters, okay? So we have to do 6 centimeters times 3 centimeters for this one, okay? And that is going to be 18. 6 times 3 is 18, and because it's an area, it's going to be centimeters squared, okay? So now I found the areas of the top, the front side and top of the shape. I need to add them all together. So I've got 24 meters squared plus 12 centimeters squared plus 18 centimeters squared. So just add them up. So 4 plus 2 plus 8. So that's going to be 14. So 1 and carry the 4. And then 2 plus 1 plus 1 plus another 1. So that's going to be 5. So the area of the front side and top panel is 54 centimeters squared. But remember, the final part of the surface area of the cuboid, we have to multiply it all by 2, okay? So 54 centimeters squared times by 2, and that is 108 centimeters squared, okay? That's the final answer for the surface area of the first cuboid, okay? Now let's have a look at the next question now, question B. Now, we're only told one dimension of this cuboid, but again, if we look at the question, we're told that shape B is a cube. So that must mean that if the base is 5 meters, that must mean the height is also 5 meters, and that the depth is also 5 meters, okay? So all the dimensions of the shape are all going to be exactly the same, okay? So let's do this again. I need to find the area of the front, side, and the top. So for the front, so that's the area of this front panel here. Well, that's going to be 5 meters times 5 meters. And that will give me an answer of 25 meters squared. For the side, that's also going to be 5 meters plus 5 meters, sorry, 5 meters times 5 meters, sorry. Let's do that again. Which is also 25 meters squared. And then the top now, that will also be 5 meters times 5 meters, okay, which is 25 meters squared. Now we need to add all of these three up. Now we could either do 25 plus 25 plus 25, or we could just do 3 times 25 meters squared, okay, and that will give you an answer of 75 meters squared, okay? It's the same as adding, rather than adding the same number 3 times, we can just multiply it by 3, okay? But that's not the final answer. Remember, we need to multiply this number by 2, okay? So then the final step now, 75 meters squared times 2, and that is 150 meters squared, okay? And that is the surface area of the cuboid for question B, okay? Let's move on to the next topic. So metric units, okay? So we're asked, so you can be asked in questions to identify what metric unit you would use to measure these objects, okay? So question A. So we're asked what we would use to measure the length of a book, okay? So let's think about the metric units of length. We've got millimeters, we've got centimeters, and we've got meters, okay? Now, millimeters are used to measure very small things like insects and plants and stuff, and meters are used to measure big things like houses and cars. So a book is somewhere in between those things, so that is why we would use centimeters to measure a book, okay? Now, question B, the amount of petrol in a car's petrol tank. So because we're talking about petrol, we're talking about liquids, okay? So that means we're talking about volumes, all right? And there's 2 measurements of volume that we know. We know there's milliliters and there are liters, okay? Now, milliliters are what you would measure if you're very, very small amounts of water, not even a drinking bottle's worth of water. So if you went to the doctors and you took some medicine, you'd literally be taking milliliters of medicine. But liters, you have liters of water. You fill a swimming pool with liters of water. Okay, so milliliters are very small measurements of volume, and liters are quite big measurements of water. So we put quite a lot of petrol in our cars, so that's why we would measure petrol in a car in liters. Okay. Now the next question. Oops, been a bit cut short, but it's the question says the weight of a bag of sugar. Okay. So the different types of masses that we know, metric masses we know. So we've got grams, got kilograms, and we've got tons. Okay. Now grams are the very small things, again, like insects and plants and stuff. And tons, we also use that to measure cars and buildings and stuff. So actually a bag of sugar is not as small as a plant and it's not as big as a car. So for a bag of sugar, we would measure it in kilograms. Okay, that's a sensible way to measure kilogram. A sensible way to measure the weight of a bag of sugar. So question D now. The distance between Newport and London. Okay, so let's think about our distances again. Okay, so millimeters are a bit too small, so we'll put it down anyway. We've got millimeters, but it's definitely not millimeters. Then we've got centimeters and we've got meters, but we also have kilometers. Okay, so we said before, thinking back to first, when we said millimeters was used to measure insects and plants, so it can't be that. Centimeters, well, we measured a book in centimeters, so it can't be that. Now, meters or kilometers. So meters, again, like we said, is to measure cars or houses. They're quite small. But a kilometer is 1,000 meters. Okay, so in this case, a kilometer is the sensible choice. If you were to measure the distance between Newport and London in meters, it would take you a long while. Okay, kilometers is the sensible answer here. Okay, so let's move on to the next part of metric units now. So metric units, converting metric units. So it's this topic can get complicated, but if you draw a conversion chart, it can make it slightly easier for you. Okay, so first of all, I'm going to do the conversion chart for lengths. Okay, so for lengths, let's change my pen. So if I have millimeters and I want to change it to centimeters, if I want to find out how many millimeters are in a centimeter, I have to divide the amount of millimeters by 10, and that will tell me how many centimeters I've got. Okay, but if I want to find out how many if I want to find out how many millimeters I've got in a centimeter, I need to multiply my centimeters by 10. Okay, let's do the next unit now. So we've done length. Now let's do volume. Okay, so the smallest volume is milliliters and the biggest volume is liters. Okay, so if I wanted to find out how many liters I had with a known amount of milliliters, because there are 1,000 milliliters in a liter, I would have to divide my milliliters by 1,000 to find out how many liters there are. Okay, and if I want to do the opposite, if I knew how many liters I had, but I wanted to find out how many milliliters I had, I would have to multiply my liters by 1,000. Okay, and the final one, if we're talking about the weights of things, we're going to be talking about the mass of things. Okay, so the smallest mass we have here are grams, and the biggest mass we've got are kilograms. Okay, so if I know how many grams I've got, and I want to find out how many kilograms I've got, because there are 1,000 grams in a kilogram, I need to divide how many grams I've got by 1,000, and that will tell me how many kilograms I've got. And if I want to do the opposite, I know how many kilograms I've got, but I want to find out what that weight is in grams. I need to multiply that by 1,000. Okay, so those are the conversion units. Those are our conversion tables. Those will tell us how to convert from millimeters to centimeters, from milliliters to liters, and from grams to kilograms. Okay, so let's answer these questions. So question E. So I'm told I have 6 centimeters and I want to find the distance in milliliters. Okay, so let's look at our chart. So I know centimeters and I want to turn it into millimeters. Okay, well that means I have to follow the green arrow. It means I have to multiply it by 10. So 6 times 10 equals 60. Therefore 6 centimeters, sorry, is 60 millimeters. Okay, now for question F, if I've got 2 kilograms and I want to know how many grams I've got, so I'm starting with kilograms and I want to see how many grams I've got. Again, I'm going from kilograms to grams, so I'm going to follow the green arrow. So I have to multiply my number by 1,000. So I have to multiply 2 by 1,000. 2 times 1,000 is 2,000. So therefore 2 kilograms is 2,000 grams. Okay, let's get rid of those. So let's have a look at the next question, question G. So we're asked to convert 870 millimeters into centimeters. Okay, so if we look at our conversion charts, we're going to start in millimeters and we want to convert it to centimeters. Okay, well that means we have to follow the blue arrow around. We have to divide by 10. Okay, so 870 divided by 10, well that's going to be 87. So therefore 870 millimeters is equal to 87 centimeters. Let's have a look at the next one now, question H. Get rid of that. So I want to convert 1,200 grams into kilograms. Okay, so I'm starting with grams and I'm converting to kilograms. Okay, so if I have to follow the blue arrow, and that tells me to divide by 1,000. Okay, so 1,200 divided by 1,000, and you should figure out that that is 1.2. Okay, so therefore 1,200 grams is equal to 1.2 kilograms. Okay, get rid of those dots. Question I want to convert 2 liters into milliliters. So I'm starting with liters and I'm converting to milliliters. So this time I have to follow the green arrow around, and the green arrow tells me to times by 1,000. So 2 times 1,000 is equal to 2,000. Therefore 2 liters is equal to 2,000 milliliters. Okay, and the last one now, I'm given 750 for question J. I'm given 750 milliliters and I'm going to convert it to liters. So starting with milliliters and turning it into liters. So this time I'm following the blue arrow around. Okay, so I have to do 750 divided by 1,000. Okay, now this one's a bit trickier. So remember, when you divide by 1,000, you move. When you divide by 1,000, we're going to move the decimal point back 3 times. Okay, and if you do that, you'll end up with 0.75. Okay, so that means that 750 milliliters is equal to 0.75 liters. Okay, and that's converting between metric units. Okay, let's have a look at the next topic. Circumference of a circle. So now the formula for circumference of a circle, just to remind you all. So circumference of a circle is equal to pi times d. Well, what is pi and what is d? So as we're told in the question, we're going to be using 3.14 for pi. Okay, so in this case, pi is equal to 3.14, and d stands for diameter of a circle. Okay, And the diameter of a circle is a line that goes through the center of it and goes to the opposite ends of the circle. Okay, so it's a line that goes all the way through a circle. Okay, and it is the total width, if you will, of that circle. So let's use this formula in practice. Okay, so for question A, we need to find the circumference of each of these circles. Okay, and just to remind you that the circumference is the distance around a circle. Okay, so we're trying to find the distance around the circle. Okay, so we know that the circumference, I'm just going to call it C for circumference, is equal to pi times d. So we know that pi is 3.14, so pi will always be 3.14 for these questions. But we need to find out what the diameter is. So looking at this circle, I can see that the length from one end of the circle to the other is 2 centimeters. So that must mean that my diameter is also 2 centimeters. Okay? Now there's two ways you can work this out. If you're able to multiply 3.14 by 2, then great, well done. You may have to do a slightly different way to solve this. So a way I would do it is I would multiply 3.14 by 100. So that gives me 314. And if I times this by 2 centimeters, I find it a bit easier to multiply non-decimals by 2. Okay, so 314 times 2, that would give me 728 centimeters. Okay, but this isn't my final answer because I times it by 100. In fact, I have to divide this by 100 now. So 728 divided by 100 will be 7.28 centimeters. And this is my final answer for my question. Okay, I just do this so it's easier to multiply decimals by. Okay, makes it easier to multiply pi. Okay, so let's have a look at another question now. So we're looking at question B now. So again, we're doing circumference equals pi times d. Well, pi is 3.14, like we said. And diameter in this case, well, this is a little bit tricky, this one, because we can see we're only told the distance to the center of the circle, okay? And we call this the radius. And the radius is half the distance of a circle across a circle, okay? But I know that the diameter of a circle is equal to the radius multiplied by 2. So therefore, if the radius in this shape is 5 meters, 5 times 2, 5 meters times 2, sorry, is going to be 10 meters. So I know that this is my diameter, 10 meters, okay? So I know the whole distance will be 10 meters. So therefore, I have to do 3.14 times 10. Now, I do need to change this anyway, because multiplying by 10 is fairly simple. All I need to do, if I've got my number, so 3.14, if my decimal point started here, I need to move it once to the right. So it would be there. So, and the answer would be, 10 meters. So the diameter of this circle is 31.4 meters, okay? And that's how we calculate the circumference of circles. So let's have a look at the next topic now. So this time we're doing the area of a circle. Now this is slightly different now. So the area of a circle, is equal to pi r squared. And there's a lot going on here. So let's break this down. So again, we're told that pi is equal to 3.14. Okay. Now r is the radius of a circle, okay? And that is the distance from the center of a circle to the edge of the circle. So it's half the distance across a circle, okay? And r squared, all that means is we have to multiply r by itself. So we have to multiply the radius by the radius, okay? So let's have a look at these first two questions. We've got question A. So let's just write area first. So area is equal to pi r squared. Okay, so pi is 3.14. We know what that is, 3.14. And we're going to times that by, so what is the radius of this shape? Well, I'm told the distance to the edge of the circle is 10 millimeters. So 3.14 times 10 millimeters squared. Okay, by this, be careful with this, so it's 10 millimeters squared. Okay, so remember, I need to square 10 millimeters. So let's rewrite this again. So 3.14 times 10. What's 10 times 10? So 10 times 10. 10 millimeters times 10 millimeters. So that will equal 3.14 times 100 millimeters squared. Okay, so I multiply these two together. So 10 times 10 is 100. And because they're both millimeters, it's millimeters squared now. Okay, so 3.14 times 100. Well, that's nice and easy. So if I write 3.14, because I'm multiplying by 100, I have to bounce the decimal point to the right twice. Okay, so my new decimal point will go here. Get rid of this decimal point. Ooh, not the 3. So 3.14 times 100 millimeters squared will be 314 millimeters squared. Okay, so that's the final answer to question A. Now question B now. So again, let's block this off, sorry. So again, area equals pi r squared. Okay, so pi is 3.14, and I need to times that by the radius, but I'm only told the diameter this time. I'm told that the diameter of this circle is 200 kilometers. So the radius is equal to the diameter divided by 2. Okay, diameter divided by 2. Okay, and in this case, if the diameter is 200 kilometers, 200 kilometers divided by 2 is 100 kilometers. Okay, so that's my radius. So I need to do 3.14 times 100 kilometers squared. Okay, now remember, when we square it, we have to times it by itself. So let's rewrite this again. So 3.14 times 100 kilometers times 100 kilometers. So let's solve this first. So 100 times 100 is 10,000. And because they're both in kilometers, it's going to be kilometers squared. Okay, so I need to do 3.14 times 10,000 kilometers squared. And so to do this, well, we start off by writing 3.14. We count how many zeros are in 10,000. There's 1, 2, 3, 4 zeros. So I need to bounce the decimal point 4 times. So 1, 2, 3, 4. Decimal point goes there. Draw a 0 under every arch. Get rid of the old decimal point. Oh, and 3. Always get rid of the 3. So we're told now, we can get rid of this decimal point because it's at the end. We're told that 3.14 times 10,000 kilometers squared is equal to 31,400, and don't forget the units, kilometers squared. Okay, and that's our final answer for the area of the circle question B. Okay, so last topic now. Okay, so final question now. So we are asked to calculate the area and the perimeter of this shape below. Okay, so we're going to start with the perimeter because that's actually going to help us with the second part of the question. Okay, so perimeter. So the perimeter is going to be equal to all of these sides added up. Okay, so we've got 9 meters. So equals 9 meters plus 7 meters plus 15 meters plus 18 meters. And hang on a minute, we're missing 2 sides. We can't solve this yet because we're missing this side. So we need to add a question mark. And we also need to add, there's another side we don't know, so we've got two unknowns. Okay, so how are we going to figure these out? Well, let's deal with the green one. Let's deal with the green one first. Okay, so we can see that the 18-meter side is pointing in the same direction as the green side. Okay, so I'm going to bring the 18-meter line a bit closer here. So I know that this red line is 18 meters. Okay, and I can also see the 7-meter line, the other side of the shape, is also pointing the same way as the green line. So I'm going to bring that green line a bit closer as well. Okay, that's 7 meters there. Now I can now see that the 18-meter line is equal to 7 meters and this unknown distance here. Okay, so let's just jot that down. So I can see that 18 meters is equal to 7 meters plus my unknown distance in meters. Okay, so I need to think 18 equals 7 plus something. What can I add to 7 to get 18? Well, hopefully you can figure out that it is 11. Okay, you can double check this. So 18 meters, 7 plus 11 is indeed 18. So I'm happy with this. This is good. So I can correct this green arrow to say 11 meters. And I can update the shape here. Okay. Now I'm going to get rid of these lines. We still need to find the blue shape now. Okay. So I've got my blue shape here. I'm going to call that question mark again. Now, what lines do I know that are pointing in the same direction as the blue line? Well, I've got 15 meters there. So if I draw a line all the way across here, I know that this line is 15 meters long. And I've already got a line here, 9 meters. That's there. So actually what I'm going to do, I'm going to bring the blue line closer up here now. So now if I compare these two lines, I can see that the 15-meter line is the same length as 9 meters plus this question mark here. Okay, so 15 meters is equal to 9 meters plus our unknown distance. Okay, so 9 plus something is 15. You should be able to figure that out. Is going to be 6 meters. Let's redraw the rest of it in. So 15 meters equal 9 meters plus 6 meters. That's good. 9 plus 6 is 15. Brilliant. So I'm going to go and I'm going to get rid of all this and I'm going to re-update our shape now. So now we know all the distances. Fix this. Okay. So now we just need to add all of these numbers up now. Okay. So we're going to do, let's just take it up here now. So we've got 9 plus 7 plus 15 plus 18 plus 6. Okay. Ooh, and 11. You forgot about 11 there. Plus 11. Okay. So this is going to be quite a tricky one. So let's work this together. So 9 plus 7 is 16. 16 plus 15 is 31. 31 plus 18 is 49. 49 plus 6 is 55. And 55 plus 11 is 66 centimeters. Oops, sorry, meters. Sorry, not centimeters, meters. Okay. So this is our final distance for the perimeter of our shape. So 66 meters. Okay. So we've done that. Now we need to find the area of the shape now. Okay. So the area of the shape. So I'm going to split this compound shape, because remember this compound shape it's as if we've stuck two smaller shapes together. Okay, and in this case we've stuck two rectangles together. So I'm just going to divide this shape up now. So I've got two nice and convenient rectangles. Okay, so I'm going to divide it like So, okay. So now I've got shape 1 and I've got shape 2. Okay. So the area is going to be the area of shape 1 plus the area of shape 2. Okay. So let's find out what they are. So area of 1. Remember, the area of a shape is the base times the height. So for shape 1, I can see it's got a base of 15 and a height of 7. So 15 times 7. I know that 10 times 7 is 70, and I know that 5 times 7 is 35. So 70 plus 35 is 105, and that's going to be in meters squared. So it's an area. So area of 1. And then finally, the area of rectangle 2. We've got a base of 6 and a height of 11. So 6 times 11. That will give us 66 meters squared, because it's all measured in meters. So in the final step now, to find the area of the whole shape, we need to add the areas of 1 and 2. So the area of 1 was 105 meters squared. Area of shape 2 was 66 meters squared. And if you add those two up, you should get 171 meters squared. And that is the final answer to the area of this compound shape, 171 meters squared. Okay. So very well done, guys. Good work. It's a long video, this, but this is the revision for the entire shape 1 module. So if you are happy with all those questions, then you're on track to do well for the module. Okay. Good work today, guys, and I'll see you next lesson. Bye now.